Okay, today we're going to look at logarithmic functions. Now it says the inverse of the exponential function is the logarithmic function. So before we delve into looking at the tables and the graphs, first thing I would like to do is show you how we get the inverse of an exponential function. So here's our exponential function, y equals b to the x power. Remember, the base can be anything, any number greater than 0. Okay, so the inverse of an exponential function shown here is a logarithmic function. So in order to do that, if you'll recall, to find the inverse of a function, what is the first step that we need to do? Right, switch the x and the y. So I'm going to go ahead and write it in this format. I'm going to go ahead and switch the x and the y. Remember, to find the inverse of a function, you switch the x and the y, and then what do you do next? Correct, you solve for y. So remember that when solving for a variable in the exponent, we need to use logarithms. So in order to get this out of the exponent, we need to take the log of both sides. So we're going to take the log of x, and then we're going to do the log of b to the y. Take the log of both sides. Now remember that the next thing we can do now is we can take the exponent and we can move it down front. So I'm going to write it down here. So the exponent moves into the front of that log. Oops, that's a y. We're solving for y. Okay, then we're going to take and divide both sides. Remember, we're trying to isolate the y here, so we're going to divide both sides by the log of b. Okay, so we're going to end up with y equals, I'm going to go ahead and switch them around, y equals, and then I'm going to rewrite this. Anytime you divide a log by a log, okay, this is called the argument of the log. Okay, this argument right here is going to become the base of the log, which is right down here. Okay, and then this argument x is going to stay the argument. This is called change of base, because this is base b. The base is the little number down below right here. This is the base. Okay, that's going to be, this argument becomes the base. This argument becomes the argument of our new logarithm. And of course I could put the inverse, because we're showing the inverse of y. The original function was b to the x. The inverse of our original function is log base b of x. Again, we say log base b of x. So one more time. The inverse of an exponential function is a logarithmic function. Okay. Let's take a look at some examples. What is the inverse of f of x equals 2 to the x? So first thing we're going to do is we're going to graph 2 to the x power and its inverse on the graph below. Alright, so we have 2 to the negative 2 power. So let's do the work right over here. 2 to the negative 2 power. Since we have a negative exponent, we need to put that in the denominator. So we're going to have 1 over 2 squared, which is going to be 1/4. Okay, 2 to the negative 1 power. 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 2 to the negative 1 power So we're going to have 1 over 2 to the first, or 1/2. And then 2 to the 0 we know is 1. 2 to the first, 2 squared, 2 to the third. Okay, so we can go ahead and graph this function. So at -2, we're at 1/4. At -1, we're at 1/2. At 0, we're at 1. See, there's that special point of ours, 0, 1. 1, 2, 2, 4, and then 3, 8. Alright, here's our exponential function, 2 to the x power. And don't forget, we do have a horizontal asymptote here for that one. Okay, now I'm going to look at the inverse. So do you remember how to find the inverse when given a table? Yes, we switch the x and the y, that's correct. So the inverse of this point is going to be 1/4 -2, switching, and so on. To find the inverse, the most important thing to remember is that you switch the x and the y. Okay, let's plot these points. I'm going to go use a pen. I'm going to be brave here and use a pen. So I have a little bit different color. It's black. So 1/4 -2. Try to be careful here. 1/2 -1. 1, 0. 2, 1. 3, 4, 2. 5, 6, 7, 8, 3. Alright, here is, if I can be real careful, this is going to be our inverse function. It's going to go through these points, just like that.